Welcome to Agentic AI in Life Sciences, Part 1. This video focuses on the regulatory pathways, governance frameworks, and practical prompting techniques essential for the next generation of AI-driven clinical innovation. This program is brought to you by the Series of Thoughts team as part of the AI Foundation series. This course explores the integration of artificial intelligence into the life sciences, from regulatory assurance to the practical mechanics of prompting large language models. You will gain fluency in risk management across the entire AI lifecycle, from initial development through post-market surveillance. This program is designed around 5 interconnected pillars. You will master data protection and privacy, compliance and lean assurance, trust and accountability, prompting fundamentals, and role-based prompting for reliable outputs. Module 1 covers protecting sensitive data. The data handled in life sciences is highly sensitive, including electronic health records and genomic sequences. This module teaches you to identify privacy risks and align your practices with global regulatory frameworks. Life sciences AI systems process data with the highest regulatory sensitivity. Understanding the unique vulnerability of health and genomic data is crucial. Mishandling this data can lead to severe consequences, including loss of public trust and regulatory fines. Key privacy risks include re-identification attacks, model memorization, data linkage from multiple sources, and jurisdictional complexity from cross-border transfers. Addressing these requires proactive security measures. HIPAA and GDPR form the backbone of data protection. While HIPAA focuses on U.S.-covered entities handling PHI, GDPR applies to any organization processing EU resident data. Both demand rigorous controls over personal health data. Building trust requires a defense in-depth approach. This includes encryption at rest and in transit, role-based access control with granular permissions, and continuous monitoring for automated anomaly detection and rapid incident response. Module 2 focuses on compliance and lean assurance. This module covers frameworks, risk analysis methodologies, and vigilance practices for AI as a medical device, or SAMD. We will explore lean assurance principles that balance regulatory rigor with development agility. Regulation matters because errors in healthcare AI carry life or death consequences. Clinical A. I must demonstrate safety and efficacy through rigorous evidence. Regulatory bodies like the FDA, EMA, and WHO are rapidly evolving their frameworks to meet these challenges. Software as a medical device, or SAMD, is software used for medical purposes without being part of a hardware device. Risk is categorized from Class 1, or wellness, to Class 4, which is critical for life-threatening conditions. Higher risk requires more extensive evidence and surveillance. Effective risk management requires a structured, iterative risk analysis framework. This continuous cycle includes hazard identification, risk estimation, risk control, and residual risk evaluation. The analysis must be revisited as AI models are updated or exposed to new data. Lean assurance adapts agile practices to regulatory requirements. It emphasizes right-sized documentation based on risk, continuous validation, evidence-based iteration, and early, frequent stakeholder alignment to prevent costly rework. Bias in Clinical A. I can amplify health disparities. Mitigation is required at every stage, ensuring demographic representation in data collection, using fairness-aware training, analyzing subgroup performance and validation, and monitoring for performance drift in deployment. Post-market vigilance ensures AI systems remain safe and effective in the real world. This involves real-world monitoring against performance thresholds, clear adverse event reporting, periodic reviews of safety and utility, and implementing corrective actions. Module 3 focuses on building trust and accountability. In high-stakes fields, A. I must earn trust through documentation, transparency, and clear accountability. We cover governance structures and ethical frameworks, from model cards to institutional review processes. The pillars of AI trust include comprehensive documentation, end-to-end traceability of model predictions, strong governance structures like ethics boards, and adherence to ethical standards such as beneficence and non-maleficence. Documentation best practices rely on model cards, which act as a nutrition label summarizing intended use, limitations, and performance metrics. Data sheets for datasets complement this by documenting provenance, composition, and collection methodology. Effective governance is a living system of accountability structures. It involves a central AI ethics board coordinating with the Data Governance Office, the Technical Review Panel, Regulatory Affairs Team, and the Clinical Oversight Committee. By the end of Modules 1 through 3, you will know how to assemble a comprehensive regulatory-ready dossier. This central artifact of trust includes privacy and security evidence, the regulatory compliance package, and the governance and ethics record. Module 4 introduces prompting for effective LLM reasoning and planning. We shift to the practical mechanics of working with large language models, establishing the vocabulary for agentic AI systems that can reason, plan, and take action. Agentic AI systems go beyond simple text generation to reason through multi-step problems, plan actions, use tools, and iterate on outputs. In life sciences, this is vital for complex workflows like clinical trial protocol drafting and regulatory document generation. A well-structured prompt is the interface between human intent and AI execution. Its anatomy includes defining the system context and the AI's role, providing a clear task specification and input data, and setting explicit output constraints. This course assumes a foundational understanding of life sciences, AI/ML concepts, Python basics for coding exercises, and regulatory awareness. Hands-on exercises will use Jupyter notebooks and LLM API access. The prompting spectrum covers 3 approaches: role-based prompting to control expertise and style, chain of thought, or COT, to elicit step-by-step reasoning, and react prompting, which combines reasoning with action and tool use in Python. Module 5 focuses on role-based prompting. By assigning a specific professional identity to the model, you fundamentally shape the expertise, vocabulary, reasoning depth, and communication style of every response it generates. Assigning a role activates specific clusters of knowledge and behavior patterns in the LLM. This allows for expertise activation, tone calibration, defining the reasoning style, and shaping how the model frames and prioritizes information. An effective role prompt is comprehensive, defining the model's identity, expertise, context, audience, constraints, and objective. For example, assigning a, quote, senior clinical reviewer role ensures formal analysis and adherence to regulatory standards. Role-based prompting is highly useful in life sciences. Use cases include prompting the model as a biostatistician for clinical trial design, a regulatory affairs specialist for regulatory writing, or a health literacy expert for patient communication materials. Common pitfalls include the authority trap, where the model generates confident but unverified claims, role drift in long conversations, and conflicting constraints, like asking the model to be both creative and strictly evidence-based, should also be avoided. Advanced topics include chain of thought, or COT, which makes the model's reasoning explicit and auditable for tasks like benefit-risk assessment. React prompting interleaves reasoning with concrete actions like querying databases and executing code, creating agentic workflows. Effective AI systems in life sciences are never finished. This course emphasizes structured feedback loops to evaluate AI outputs, identify failure modes, and drive continuous improvement across the model lifecycle. The principle is always to measure, learn, and adapt. The capstone application is adaptive clinical trial feasibility. AI agents bring together all concepts to evaluate feasibility by performing data gathering, feasibility analysis, design optimization, regulatory alignment, and presenting recommendations for human review. The key takeaways are: data protection is non-negotiable, lean assurance balances rigor and agility, trust is built through transparency, and prompting is a professional skill. These foundations enable responsible and effective AI deployment. In Part 2, we will dive deeper into hands-on implementation of chain of thought and React agents in Python. We will apply these techniques to real-world scenarios and complete the comprehensive, submission-ready regulatory dossier.